Hey everyone, and welcome back. In this video, we're going to be going over some problems that you might encounter or very similar problems to what you will see in the Algebra Mastery exam. So without further ado, let's jump right into it. Remember that you must have these 8 lines in order for you to do any type of algebra and any type of calculus, any type of differential equations. So these 8 lines are extremely important. The first 3 help us do more complicated stuff like algebra and calculus and trigonometry. This next 4 help us link our Google Drive and our Colab. And lastly, the important math 280 helps us do the differential equations part. So don't forget to have these 8 lines at the beginning of every document you do from now on. So after we run it, let's jump into the previously seen commands. So some previously seen commands would be the ones that you've seen on the test drive or that we've already used before. So in this case, solve set is one of them. And remember that solve set helps us find the value of a variable. It's kind of like solve, and it will give us all the possible values for that variable. So it would plug in a quadratic formula. It would give us 2 possible solutions, maybe 1. It just depends. So remember, the syntax would be solve set, the expression or equality. Remember, you can use solve set with in conjunction with equality to solve for variables, and then the variable, comma the variable you're solving for. So the next one would be equality. Remember that equality in math and in Python don't actually mean the exact same thing. Equality in Python refers to assigning a value to something, and here equality would be more of what we're familiar with in math. So if I wanted to say A equals B or write that expression down, I say EQ A comma B. The next one will be factor. Factor, like the name suggests, it's pretty straightforward. We factor an expression, and there's 2 syntax for it. There's factor expression, which is a function syntax, or the way Python would think about it, an object-oriented syntax would be as simple as writing the expression dot factor. Same idea with expand. Expand also has that function syntax and oriented syntax, object-oriented syntax, and it works exactly the same. Expand expression or expression dot expand. Similar to both the previous ones, both expand and factor. Simplify does the exact same thing. You can simplify the expression, or you can write the expression dot simplify. So those are commands that you've seen before, perhaps in the test drive and in other documents. So what are the new things that you might see in this document? So first thing is adding an image. So we haven't taught you how to add an image. So here's a step-by-step solution on how to do it. I will give a little example. First, we get a snipping tool. Then we select the picture we want to import into the Google Colab. Then we click copy, right-click copy. And then here we open a text cell and then Control V or Control or paste it. After we paste it, we're going to see this jumbo. Don't worry about it. Just press Shift Enter, and you should get your picture in that text cell. So that's how you add an image. Another command that you're going to be using a lot for algebra is going to be subs. Subs is basically short for substitute, and that's if you want to add a numerical value or if you want to substitute variables for other variables, we use subs. So in this case, if I wanted to say instead of f of x, I wanted to say f of a or f3 or f of 10, well, we use a subs command. So here's a little example. Let's say I have the expression f equals x squared plus 1. If I wanted to substitute f for a or x for a such that we get f of a, we just write f dot subs x comma a. And that will substitute all instances of x for a's. We can also do numerical values. So if I wanted to say f of 3, I would put f dot subs x comma 3. So a variable that you want to change with the value that you want to add. So in this case, 3 will go into the x value, so it would be 3 squared plus 1, so that's 10, and this should give us the value. So yeah, that's how you use subs. Subs, again, is just for plugging in values into functions. Lastly, plot. This will be used for later on, like problem 8, I believe. And the way you use plot is by writing an expression down and then plot f, or plot the expression. So the syntax is actually pretty simple, and the command is actually also pretty simple. All right, so those are all the commands that you might see that you might encounter in this mastery exam. So let's jump into the mastery exam. So first, I decided to write all the symbols or all the variables that I might be using in the mastery exam. This is just for sake of cleanliness and for me not to having to like retype everything over and over again. This is up to you. This is just a way that I like to organize things. So to solve for the variable x, we would be using solve set, and notice that it's an equality. So inside solve set, we are going to be adding an equality. So to do that, we just write solve set, and inside solve set the equality. And the equality is just 1 over x minus 6 plus 2, comma, comma, x over x minus 6. And after I write down the equality, I need to write the variable we're solving for. So in this case, x. As soon as we enter it, it should give us 11. So you can plug this in back in and see that it's actually correct. Another thing we can do is that we can solve for variables in terms of other variables, which is what we're going to be using for problem 2. And notice that it's the exact same commands. We use solve set, and then inside it's an equality, because the expression that they gave us is an equality. 2 times w plus 2 times y, comma, 164 plus 9 times y, and then we're solving for y. And there we have it. If you try solving for y by hand, you should be getting this expression down. Now, problem 3 is going to ask you to factor, and that's actually pretty simple. We just write the command factor, and inside factor we write the expression. So in this case, it would be 9 times x squared minus 6x plus 1. And notice if we write it this way, or if we write it in the function syntax or object-oriented syntax, should give us the exact same thing. Same thing for the next question. It will be factor 49 minus t squared. And if we write it in the object-oriented syntax, gives us the exact same answer. What's the difference between these two is just the syntax. And honestly, in this type of scenarios, I would prefer to use the function syntax because I do not have to write extra parentheses for the expression. However, if I were to call this expression something else like g, then it would be much easier to say g dot factor rather than saying factor and then inside parentheses g. So it just depends on the situation. And in this case, it's easier to use the function syntax. So to expand, we use the expand command. So expand inside the parentheses, we're going to have two things. We're going to have x plus a times x plus b. So we expand it. We should get the exact same thing as if we did the object-oriented syntax. Yep. And then for the last one, expand. This one has more parentheses. Z plus 2 times w. Then that's squared. And alternatively, again, we can use the object-oriented syntax. And there we go. Again, I would recommend using the function syntax because this is like a long an expression, and it would just take longer if you had to like put the extra parentheses down. Whereas if I were to have called x plus a times x plus b like f, then it would be easier to just say f dot expand. All right, problem 5 is going to ask you to do the substitution and then to simplify the value of f of a plus h minus f of a when f is equal to 5x squared. So first things first, we have to state that f is equal to 5 times x squared. Verify that we did it correctly. There we go. Then we can substitute a plus h for f, so f dot subs, and then x comma a plus h. All right, so it did substitute it properly. Next, we substitute f for f of a. So f dot subs a, x comma a. That's also substituted properly. And then lastly, we say that what's the difference between these two. So we do that minus 5 times a squared. All right, and then we just want to simplify. So simplify what we just did. So, and there we have it. So I did this step by step, but you can actually do it in one line. We can write first that we want to simplify, and what do we want to simplify? Well, we want to simplify the difference between substituting for a plus h minus substituting for a. So we can actually just write inside the simplify that computation. So in this case, we're simplifying f substituting x for a plus h. So this is f of a plus h minus f of a, which is what the subs is doing. So if we run this, we should get the exact same value. So for problem 6, we're going to be simplifying as much as possible. So in this case, we can just use the simplify command. So simplify for the first part. Simplify x minus and the fraction 1 over x plus 1 over x. And there we go. That's as much as we can simplify. Next, we use for the next part would be simplify again. And in this case, it's first would be 4 times x to the power of -1 times y to the power of, and then remember we can call rational to write the fraction down, 4,3. And outside of that, raise that to the power of 3/2. So rational 3,2. And then divide all that by x. And there we have it. That's a simplification. If we try expanding this or factoring this, we get the exact same expression. So this is simple. That's how we know that this is simplified as much as possible. All right, for problem 8, we have to find where the graph intersects the x and the y axes. So first, let's plot them. So we will be using the command plot to plot these. Okay, let's redo that. So for problem 8, we want to find where the graphs intersect the x-axis and the y-axis. So the first thing we do is that we're going to be writing the expression down, and with the command plot, we're going to be plotting that. So first, y is equal to x over 2 plus 2. And let's plot y. All right, so we have that graph, and notice that from the graph we can see that the y-intercept is about 2, and the x-intercept is about like -3, -4, somewhere around that. So we can use subs to find the y-intercept by substituting x for 0 and solving for y. So in this case, if we do y dot subs x comma 0, we should get the y-intercept. So in this case, it's 2, and that's how we know it's correct. We can use solve set to solve for x when y is equal to 0. So remember that solve set, if you do not put an equality or something like that, it would automatically try solving for when the expression is equal to 0. In this case, the expression is called y, so we could just say solve set y comma x. This is substituting the expression x over 2 plus 2. So when we input y, we actually mean x over 2 plus 2 equals 0. Basically setting y is equal to 0. So solve set y comma x should give us the x-intercept, and there we go, it's -4, so that's how we know it's correct. Lastly, let's do the next expression. So y is equal to 2 times x squared minus 12 times x, if I recall correctly. Yep, plus 18, and then plot y. So we should be getting a parabola. There we go. And lastly, to solve for its x-intercept and y-intercept, first let's do y-intercept. So y dot subs x comma 0 versus finding the x-intercept, which is just solve set y comma x, and which is about 3. So yeah. Lastly, to export our document to our Moodle page, we remember to use this command, math280.export to HTML, and inside it would be the name of the document within some quotation marks. So after we run that and go to our Google Drive, we should be able to see in a bit, hopefully. There it is. After reloading a couple of times, we should be able to see the master exam in there. Right click on it and download it. After it's downloaded, we can print it. So print, right click print, and just print as a PDF file. So yeah, in this video, we went over the Algebra Mastery exam, and in the next video, we're going to be going over the Calculus 1 Mastery exam. So until that video, I'll see you around. Bye-bye.